Hey coders, welcome back to Code Streak Daily. In today's video, we are going to explore a fascinating problem where we have to determine which chair a friend sits on at a party using Python. Okay, so the question title is the number of smallest unoccupied chairs, and it's a medium level difficulty problem. Let me read out the description. There is a party where n friends number from 0 to n minus 1 are attending. There is an infinite number of chairs in the party that are numbered from 0 to infinity. When a friend arrives at the party, they sit on unoccupied chair with the smallest number. For example, if chairs 0, 1 and 5 are occupied, when a friend comes, they will sit on the chair number 2. And when a friend leaves the party, the chair becomes unoccupied at the moment they leave. If another friend arrives at the same moment, they can sit on that chair. Okay. You are given a zero indexed 2D array, integer array, times, where times of I equals arrival and leaving, indicating that the arrival and leaving times of the ith friend respectively and an integer target friend. All arrival times are distinct. We have to return the chain number that the friend number target friend will sit on. Okay, here we have the array times, and it's a 2D array. We have the values 1 and 4, 2 and 3, and 4 and 6. uh, Target friend equals to 1. So let's see the explanation here. Friend 0 arrives at the time 1. This is the time, arrival time, and sits on the chair 0. Okay, and friend 1 arrives at the time 2 and sits on the chair 1. Friend 1 leaves at the time 3 and chair 1 becomes empty. So it's the time of leaving. And friend 0 leaves at the time 4 and chair 0 becomes empty. Okay. Friend 2 arrives at the time 4 and sits on the chair 0 because the first friend has already left, so the chair 0 will be empty. So the friend who arrives at that moment will sit on the chair 0. Since friend 1 sat on chair 1, we have to return 1. Okay. The same happens here. Okay. Um, Now, here we have to write the code to identify where a new friend when comes sits on which chair. Okay. Um, First of all, we have to do this problem using the heap queue. Okay, I'm gonna import heap queue, which will allow us to work with the heaps or priority queues in Python. This is crucial for efficiently managing the available chairs. Okay, so now here we have the function smallest chair, and here we have the list. It's a 2D list, and we also have an integer target friend. Okay, now I have to know what's the length of the 2D array. Okay, so this function takes two parameters, right? The it can a list of arrival and departure times for each friend and the target friend. Okay, now I need the length of the times. N equals to length of times. Okay, now we have to create an arrivals list which pairs each friend's arrival time with their index values, and then we sort this list so we can process with each friend based on arrival time. Sorting ensures that we handle arrival times in the correct order. Okay, so I'm taking arrivals equals to uh, times of I and 0 and uh, comma I. Okay, I'm taking a for loop here for I in range of n. Sorry, n. Okay, now I'm gonna sort the list arrivals dot sort. Okay, now we have to initialize the min heap for available chairs. Okay, so I'm taking it as available chairs equals to, I'm taking it as a list of range of n. Okay, then I'm gonna I have initialized this list available chair containing chairs number from 0 to n minus 1 representing the smallest available chairs. Okay, now we have to use heap queue.heapify. We convert this list into a min heap which lets us efficiently extract the smallest available chair when a friend arrives. Okay, so I'm gonna write heap q dot heapify of available chairs. Okay, now we have to make a priority queue for tracking the vacated chairs. Okay, so I'm taking it as leaving queue. I hope the spelling's correct. Okay, leaving queue. I'm making it as an empty list. Now this allows us to track when friends leave their chairs. So we know when a chair becomes available again, the smallest chair. Okay, now we have to process each friend's arrival, right? So for arrival time, and we also need the friend index, right? Friend index in arrivals. Um, I'm taking a while loop while leaving queue and leaving queue the first row in column. We have to check whether it is less than or equal to arrival time. In that case, what we have to do? We have to push, right? Heap queue dot heap push available um, chairs as well as um, we also need heap queue dot heap pop, both the operations pushing and popping, leaving queue of 1. Okay, so I'll tell you what we are doing that. In this loop, we will iterate through the sorted arrivals list first, and for each friend's arrival, we will check. We will first check the leaving queue to see if any friends have left before or at the current arrival time. If so, we will free up their chair by pushing it into the available chairs heap. Okay, then we have to assign the smallest chair, right? Now for assigning the smallest chair, I'm taking a variable called, sorry, I'm taking a variable called, we have to exit the for loop, sorry, while loop. I'm taking a variable called chair equals heap q dot heap pop of available chairs. Okay, once we have handled the vacated chairs, we will assign the smallest available chair to the current friend using this heap q dot heap pop. This will always gives us the smallest chair number as we are working with the min heap. Okay, now we have to check if it is a target friend or not. Okay, for that, if friend index equals target friend, in that case we have to return the chair number. Okay, that would be our answer. And again we have to track when the chair becomes available again, right? So for that, heap queue dot heap push, here I am to take leaving queue, comma, also we need the times of friend index of 1, as well as we also need the chair. Okay, if it's not the target friend, we push their leave time and the chair number into the leaving queue. So we know when this chair will be available again. Okay, let me run the code. Okay, as you see, the test cases have been passed successfully. Now let me submit the code and check if all the test cases will pass or not. Yeah, as you can see, all the test cases have been passed and our runtime is 550 milliseconds and it beats 85.29% of users. Okay, so that's how the program works, and once we find the chair for the target friend, the function returns the result. Okay, this approach runs efficiently with a time complexity of order of n log n, because we are basically using the heaps, so it takes very less time. Okay, that's it for today's coding tutorial. I hope this explanation helped you understand how to solve the problem using heaps. Don't forget to like the video and do subscribe to Code Stick Daily and let me know your thoughts in the comments. And if you have any further efficient code than this, do put that in the comment of this video. I'll surely check on that. And if you want more coding tutorials and if you want to keep maintaining your streak in both Geek for Geeks and also in Leetcode, do subscribe to our channel. And if you have any thoughts, please do put that in the comments. And keep sticking, guys. I'll see you in the next video.